Have you ever looked up at the night sky and wondered what's out there, beyond the stars, beyond the galaxies, beyond the known universe? Somewhere out there, hidden in the dark, are the most mysterious, terrifying, and awe-inspiring objects in the cosmos: black holes. But what is a black hole? Imagine a place in space where gravity is so strong not even light, the fastest thing in the universe, can escape. A place where space and time get twisted into a funnel, pulling everything into a bottomless abyss. That's a black hole. It's not just a really dense object. It's a region of space-time that literally breaks our understanding of physics. Let's rewind a bit. Black holes begin their lives as stars, but not just any stars. We're talking massive, monstrous stars, at least 20 times the mass of our sun. These stars burn bright and hot for millions of years, fusing hydrogen into helium and then heavier and heavier elements until they can't anymore. When their fuel runs out, they collapse. In a fraction of a second, the star's core is crushed by its own gravity. The result? A singularity, an infinitely dense point in space, surrounded by an invisible boundary called the event horizon. Once you cross that boundary, there's no turning back. So what happens if you fall into one? Well, it depends. If you fall into a stellar mass black hole a few times the mass of the sun, you won't have time to think. You'll be stretched and squeezed in a process scientists call spaghettification. That's right, you'll be turned into a cosmic spaghetti noodle as gravity pulls harder on your feet than your head. Your body would be ripped apart, atom by atom, long before you reach the singularity. But, and here's the crazy part, if you fall into a supermassive black hole, the kind that lives in the centers of galaxies, you might actually survive crossing the event horizon. These giants, with millions or even billions of times the mass of the sun, have much gentler gravitational gradients. You could drift into the abyss and not even notice. You wouldn't see blackness. You wouldn't see stars. You might see the entire universe distorted in a ring around you, light from every direction warped by extreme gravity. But the moment you try to send a message back, nothing gets out. From the outside, you'd appear frozen in time. From your perspective, time might keep flowing, or completely break down. And here's where it gets truly weird. According to Einstein's general theory of relativity, space and time are one fabric, space-time. A black hole doesn't just warp space, it warps time. The closer you get to the singularity, the slower time flows. At the singularity, time might stop altogether. Or, if quantum physics has something to say about it, something even stranger could happen. Some scientists believe that black holes don't destroy information. Instead, that information might be preserved, encoded on the event horizon like a hologram. This is the heart of the black hole information paradox, one of the biggest mysteries in modern physics. And it's not just a theoretical question, it could rewrite everything we think we know about reality. Let's talk about the big ones. At the center of our Milky Way galaxy lies a monster. Sagittarius A Psi, a black hole 4 million times the mass of our sun. It sits quietly, like a sleeping giant, occasionally flaring as it devours gas, dust, and the occasional star. And it's not alone. Every major galaxy has one or more supermassive black holes at its core. They shape galaxies, bend time, and might even hold the key to understanding how our universe was born. But how do we see something that emits no light? In 2019, scientists with the Event Horizon Telescope did something incredible. They captured the first ever image of a black hole. Not the black hole itself, but its shadow. A fiery ring of superheated gas swirled around it at near light speed, glowing like a halo of doom. It was a blurry image, sure, but it was real. Humanity's first look at the edge of the unknown. Now, black holes aren't just cosmic vacuum cleaners. They don't go around sucking up everything in sight. You could orbit a black hole safely, as long as you keep your distance. In fact, some black holes are surrounded by accretion disks, swirling rings of matter that generate intense light and X-rays as they spiral in. These disks can outshine entire galaxies. And when black holes merge, they send ripples through the fabric of space-time itself. Gravitational waves. First predicted by Einstein, gravitational waves were detected for the first time in 2015. When two black holes collided over 1 billion light-years away, the shock waves traveled across the universe, and we caught them here on Earth. These waves are tiny, but they carry enormous energy, and they've opened up a whole new way of looking at the cosmos. So are black holes just cosmic dead ends? Not necessarily. Some scientists speculate that black holes could be gateways to other universes, to other dimensions, or even to the distant future. Could they be wormholes in disguise? Could something or someone survive the trip? We don't know, and maybe we never will. But one thing is clear: black holes aren't just holes in space. They are the beating hearts of galaxies, the engines of destruction and creation, and the most mysterious objects in the known universe. They challenge our physics, they challenge our imagination, and they remind us that the universe is vast, violent, beautiful, and still full of secrets. So next time you look up at the stars, remember, somewhere out there in the dark, the black holes are watching.